டைப் பண்ணு. பவர் பட்டன் பண்ணு.
ரைட்ல வந்து
Now I request Sakthivel G to give the introduction about the VIT business presentation.
Dr. G. Sakthivel is currently working as a professor, School of Mechanical Engineering, Vellore Institute of Technology, Chennai campus. He also holds the position of Deputy Director at the Center of Automation. His area of interest is on development of projects such as smart solar thermic devices and wearable robotic exoskeletons. He has also been recognized for his expertise in energy and AI. He was recognized by Stanford University as one of the top 2,000 scientists globally in 2020 for his work in energy and AI.
Thank you. Now I request Dr. G. Sakthivel to address the gathering.
Okay, so happy morning to all. We hope that the audience is most of from the students' side, mainly students' side. Certainly listen for half an hour. After that, we have interaction. We can have interaction in basics presentation. So I don't want to take into the core technology. Try to understand since you are going to graduate. Okay, so what's the need to be addressed in the agriculture? So now what you are saying that industry 4.0, industry 2.0, industry 3.0, there so many versions are there. What's the need for the automotive industry? Okay, so similarly the same strategy is going to be exported in the agricultural side. Okay, so I'm going to address only the real-time challenges what we are facing and what's the technologies to be there in agriculture. That's the thing I'm going to address here. I don't want to go into the core technology since you are the boss. Okay, in the core technologies and you are the next generation engineers. Okay, so happy to see this next generation engineers this fall by addressing the session is an overview role of computer vision autonomous navigation for smart agriculture. So before starting the presentation, I want to convey sincere thanks to Sujata ma'am and her team. And yeah, basically I'm a mechanical engineer and done my mechatronics and completed my PhD in decision support systems in engines from Anna University. And I started my research career after completing my PhD in the automotive side, autonomous vehicles. From the autonomous vehicles, what I'm shifted to the autonomous vehicle in the agricultural side, agricultural automation. Okay, why this agricultural automation? I shifted my research from mechanical. Yeah, mechanical is the going to agricultural automation. What happens? It's a multidisciplinary field. Electronics engineers or mechanical engineers or computer engineers are joined together and to execute this all the tasks. If not, means it's very difficult because we are in the era of Agri 5.0. So within the next decade, Agri 6.0, Agri 7.0 is going to be launched. Okay. So what I'm saying that basically I am from agricultural background. So let's put that scenario as like the previous resource person addressed that. Okay, in the world, around 80% of the farmers are from the small scale farmers. Small scale farmers means middle scale farmers. What I am saying that the farmers who are in the farming unit less than 1 or 2, 3 acres. So that product is going to be high. Our GDP is based on that productivity, not with the large scale farmers. Right? You understand? Now what happens? What's the scenario is human is servicing the last 5 years. Okay. So that generations are coming to the urban or shifted to semi-urban urban scenarios for the industry backgrounds. So if it's keep on reducing means what I'm saying that food scarcity is going to be there. Okay. So let's put that challenge. I shifted my research. That means that I transferred my research to that area. Anyway, I initiated my research. Okay. So this is my background and coming to here. What are things we're going to see today's issue is motivation, global challenge in agriculture. And finally, what is smart agriculture? Okay, and what I mean by ICE. So, what's the topic is going to be is computer vision fundamental. What I am working a little bit in that area. Okay, so more on automation. But anyway, this is needed for automation. If not, means very difficult to survey in the what I am saying that develop any equipments or validate or test. Okay, and coming to the brain index, autonomous navigation systems, controllers. Again, and what happens, key applications and some real world case studies, what's happening in the European Unions and the abroads, and coming to the navigating the challenges and future trends. Okay. So, we know all the things. There are 2 scenarios in the automotive side. One is ADAS and autonomous vehicles. Okay. So, ADAS means what I am saying that, okay, adopting, what do you mean by ADAS? Autonomous vehicles, what do you mean by ADAS? What in autonomous vehicles? Autonomous driving assistance systems. Now what happens? Most of the small scale startups and even though take OEMs and tier 1, tier 2 industries are working with the ADAS. Okay. So to improve the accuracy, as ma'am said that what happens, okay, so AI in machine learning, algorithms, models, what's developed, it may vary depending upon the region based. If it goes to adopt region, it gives accuracy of 95%. If it try to adopt the same algorithm in another region, it gives 85%. Why? What's the problem is happening? Okay. So we have to refine the algorithm. We have to refine the variance. Okay. We have to develop the indigenous model. So far, it is very difficult to develop the indigenous model. Not only in agriculture, it's happening in the automotive side also. For example, if you take a Tesla FLD, who developed the autonomous vehicles, who launched the autonomous vehicles in the US, what happens? Okay, they made an attempt and some problem has happened. Unfortunately, some obstacles came and the car hits that obstacles immediately. He recalled that version from the market and again is doing the research, extensive research. Why means as you electronics engineers, okay, working with us, involved in the developing so many sensors, smart sensors, lidar sensors. What I'm saying that so many hyperspectral sensors, okay, and you have to develop sensors. That uncertainty will have to be very less, 0.0001. That it looped with the controller uncertainty has to be reduced. Then, if any obstacles have to be crossed, within a fraction of a second, I want to stop the vehicle. Okay, that is coming to autonomous vehicle. So far, it's in the research is happening in the foreign countries. It takes another 20 years to adopt in India, but leave it. Okay, coming to the ADAS, autonomous vehicles. Coming to ADAS. Okay, so even the Tata and Mahindra and so many OEMs are working in the, for example, to monitor the driver's behavior. For example, if you keep on driving the vehicle for 8 hours, okay, understood. If you keep on watching me, it's very difficult for me, okay, for you to keep on watching the class. Am I correct? So, if you feel tired, what happens immediately? The signal comes to me and says, you feel tired. Okay, so try to blame as like that. What I am saying that I want to monitor the driver's behavior, and the driver leads to fatigue. What happens? You have to be alarmed, or signal have to be goes to controller. Automatically, the speed and other accessories will be reduced. Okay, steering systems will be controlled. Okay, so these are two things are major scenario in the automotive side. Once it is launched, what happens? That's all. The automotive scenario is going to be mature. Okay, further we need smart infrastructure, other things and all. Okay, similarly, but why not this concept is going to be will have to be implemented in the agriculture side? It's possible. Okay, that transformation is happening. And one more thing I want to address here, addressing this scenario. If you take our Indian OEMs, Mahindra, Tata, okay, and other OEMs, apart from that means global OEMs, what I'm saying, all focused on the developing the agricultural machineries, harvesters, implementers. And during the corona period, for example, Mahindra's sales is very less. But what happens? The tractors sales is very good. Okay, so that is the strategy. Always what happens? It gives a sustainable GDP for India. Okay, anyway. So this is a scenario. Why we are going for global challenge in agriculture? So as per the source from the UN, okay, what is predicted in 2014 data? So our global population reaches 9.75 billion in 2050. Again, so if it reaches means, yeah, what's the problem going to be there? Arable land, limited water. Water scarcity will be there. Land shortage is also there. Farming land keep on diminishing. Okay, because most of small scale farmers are selling the farming land to the real estate developers, and coming to the shortage of skilled laborers because the next generation farmers are not ready to accommodate the farming land and want to earn more money in the shifting that pain to the urban and semi-urban areas. And coming to the most important things that we are lagging is even the laborers not there. Why we cannot do the farming? That is coming under sustainable practice. Okay, technologies are there. Okay, so many transformations happen in the automotive side. Why not? Now, all the automotive manufacturers are start to think of it. Why not we can do the transformation in the agriculture? Okay, so coming to the farming, as I said, the three types of farming. Anyway, just to give the glimpses of the basics. After that, we can go for the computer vision system. Okay, what's the need of the day? Coming to the traditional farming, precision agriculture, smart agriculture, these are the various versions of the agriculture. Again, now what's our objective is field-wide care to plant care. That is the most important thing. Okay, so field-wide means what happens if having 1 or 2 acres, what happens if I go to farming, very difficult to get the yield, productivity. Now what happens? Attention has to be given per plant, each and every plant. Okay, then only you can yield the productivity. You can get the productivity. You can get that much yield. Okay, so so traditional farming can leave uniform treatment of entire fields, inefficient, wasteful, all the things are there. Coming to precision agriculture, you can see the terminology variable rate technology. Okay, so how we can achieve this? As ma'am said that this algorithm is going to be useful for one region and it's not useful for other region. You have to fine tune it. Okay, as like that, why it's happening means this for the region based soil, natural soil may varies. Okay, growth of the plant may varies. Okay, and nutrition also may varies. Okay, so that's a problem here. Okay, so the rest of the strategy, for example, if we are having a soil, clay soil, what happens? The water supply water have to be reduced. If it's a dry soil, okay, what happens? We have to supply more water. Okay. So this algorithm is suitable for that soil and this soil. We have to change the variance anyway. So depending upon that, I can vary that means using the sensors technology, is it possible to vary the variance and for example, I can supply the water? Yes, it's possible. Okay. So that is coming in the precision agriculture. And one more thing is the final thing is smart agriculture. Okay, that is a future scope, not a future scope, already implemented. For seeding, harvesting, for all the things, including robots or smart systems. Okay. So, yeah. So this all the scenarios. Now, what's the most important is per plant care instead of per field. That's the most important thing. And coming to the precision agriculture, it is a middle level automation. If you take a task, we can say 0 level automation to 5 level automation. That means no automation to full automation. Again, so as like that, is it possible to achieve the agriculture? Yes, we are having the 5 levels of automation. Again, the supervised learning, unsupervised learning, as like that, was previous resource was not addressed. Okay. Yeah. So coming, I don't want to take more time here. Sustainable agriculture. And here, so sustainable agriculture covers the soil management. Again, since I am saying that I want to focus each and every plant. Okay, I want to get the 100% productivity. I don't want to get 80% productivity. Okay, so if you focus 80% productivity, automatically what happens after 3 years or 4 years, 80% reduced to 60%, 70%. Keep on going to continuous farming. Okay, so I want to get the soil. I want to enhance the soil. I want to monitor the soil and partly seed planting. Okay, uniform distribution of seeding have to be happen. Okay. If you go for human intervention, it's very difficult. And one more thing is that crop health monitoring and surveillance, which is related to the crop damage assessment and eco-friendly inputs and irrigation monitoring and livestock tracking is also coming under the sustainable practices in the agriculture. Okay, so what I'm saying that this all the sustainable practices we can adopt in the smart agriculture. Yeah. So just to give some small example between the precision agriculture and smart agriculture. After that, we can enter the core technology. Coming to precision agriculture. Okay. Yeah. Before going to this slide, I want to say one example. Our traditional farmers have to be equipped. Okay. Since most of the students you come from the agriculture background, means try to equip your regional farmers. I want to say one example. The government is giving more subsidies to the farmers, but what happens? The farmers is not having the awareness to know subsidies. Just I want to address an example. What's happened during before the corona? If you take a Bombay, if you take a Mumbai, what happens? Their farming land is something different when compared to southern region. Okay, so every year they want to make a bore and they want to take the water from the underground. Okay, so what happens? That's why it's something different. Once they make a bore, okay, maybe 100 meters, 200 meters. Within a year or within 1.5 years, what happens? The soil will be, it's like loose soil, again, it grows all the bores. Okay, so what happens? Maharashtra farmers have to dig the bore 2 years once or 3 years once. So, and probably the Mahendra, who is the OEM. Okay, so, for example, so due to the water scarcity, they cannot be able to do the farming. That's a major problem. So, what Mahendra make a plan with respect to business side is, why not we can give the tractors to 5 regions or 7 regions, small villages, as a free of cost. As a free of cost, try to understand it, as a free of cost. And each and every farmer try to utilize the tractors once in a month. Okay. So what happens? They are to dig the holes and want to absorb the water from the ground. And so the tractors are free of cost. Why not we use the tractors? Okay, per month, okay, this region 1, region 2, region 3, as like that, what happens? They give it to the local community and they have prepared the chart, and as per the chart, the farmers keep on using the tractors, and finally what happens? The traditional farmers identify what is usage of tractors and how the farming is very simple, how the harvesting or seeding is very simple, and probably 5 or 6 farmers combined together or 10 or 20 farmers combined together and purchase the tractors. So by giving one tractor as a subsidy to corresponding 10 villages, again, after 1.5 years or 2 years, what happens? That purchase rate, the farmers' purchase rate from the regions keeps on increasing. That means they sold around 30 tractors to the corresponding region. Okay, that means by the subsidy, 50% subsidy from the Maharashtra government. That means what I am saying that so many schemes are there, but it's not reaching to the farmers. We don't have educated farmers. That is a major problem. Anyway, so coming to this side, precision agriculture, you can see that. Okay, the satellite image is that remote sensing. Let's put remote sensing. Just taking a satellite image, we have some signatures. Okay, that means from the corresponding region. Okay, value going to harvesting and while the harvesting is happened. Okay, so and the signatures, from the signatures we can identify that normalized difference vegetation index. That means growth level of the corresponding plant or corresponding region. Okay, so and similarly we have one more technologies are there. Okay, validated technologies. We have techniques. Spectroradiometer is there. So we have to filter radiometer and again we have to identify what's the signatures lively from the real-time region. Okay, that is remote sensing. Here lively from the having intervention with the plant without disturbing the leaves of plant. Okay, and take the data and try to validate. That's for validation. And how far the observed data from the remote sensing is precise. Okay, so once validation is happened, fine. Okay, if some deficiencies are there, or is there or not a problem. Okay, so let's try to validate, and if any differences there are, so case is called as coefficient. Okay, so we are having some coefficients and the NDVIs, and depending upon that, okay, you can see that the water requirement, the water is fed to the irrigation level. That means water is fed to the regional side. And one more thing here, you can see that either side. You can see the weather climate. Okay, from the monsoons, from the climatic zone. Okay, what happens? We have to forecast the weather, and that weather is also interpreted with the remote sensing data and the observed real-time data. And parallelly, okay, this data says that okay, we need 20 liters of water or 40 liters of water. But meanwhile, the weather climate says that okay, within 2 years, within 2 hours or 3 hours, okay, what happens? We are going to get 2 centimeters of water. Then that's not to supply the water. You have to cut off the water. Okay, this is comes under precision agriculture. Okay. Yeah, coming to the smart agriculture. As I already said, what's the difference between precision agriculture and smart agriculture? These are 3 examples what I shown in the smart agriculture. Again, the same strategies using the drones. Instead of remote sensing, very difficult to get the clarity image since we are facing the problems. Okay, so get a precise image. What I said is not just to region is per plant. My focus should be that. My yield should be that. Okay, so if I use this drones, okay, drones or robotics technologies needed. Here I am attaching the drones. So with the drones, I have to capture the data, and that data having several spectral signatures. That means several signatures and we have to feed it in the AI-based systems. Meanwhile, you can see the same strategy what I seen in the previous slide, the remote sensing. Instead of remote sensing, we are seeing the drones. Okay, and we are taking the weather data and whether water should be needed or not. Decision support systems will be taken automatically and feed the water in to the irrigation line. Okay. Similarly, and one more example, you can see that fertilizer. The same drones. What's data is observed? Okay, whether growth level is good or not, vegetation index is good or not. Okay, or the nutrition of the soil is good, nutrition of the plant growth is good or not, nutrition of soil is good or not. As ma'am said, that NPK level is okay or not. Okay, these all the things observed from the soil using drones and goes to the some developed apps, some intervention devices, and says that this much fertilizer is needed. Because this is in the starting stage, you have to spray the fertilizers. Our growth level is very less, NDVI level is very less. We have to spray the fertilizer. As like that, the decision is given automatically to the sprayers or whatever to the devices to spray the fertilizer automatically. Okay. And coming to the next step is you can see the last this side below this. Okay, you can see the mobile the water spraying. There is only a drone to observe what's happened in the field. But coming here, what's observed in the field, and if I want to spray the fertilizer or spray the water, nowadays I don't go for drip irrigation or sprinkler irrigation because it's a waste of time. Okay, if you fix the drip irrigation, what happens? The drip irrigation will be triggered by giving a constant pressure. What I said is per plant. Okay, with respect to this region is well enhanced and growth level is very good. But this region is not, growth level is not good. What I am saying that here, I am fixed the drip irrigation, the water pressure is good and the water reach level is very good. But coming to here, the pressure is reduced since the water pressure is taken more here and the reach level is good, the pressure drop is up here. So what happens? So the reach level of the water is not up to that last level. What I am saying that the growth level of the corresponding region is diminished. Okay, so there's so much difference are there. So to avoid this thing, I can use the drones to spray the fertilizers, to spray the waters. Okay, this is scenario is what we needed for the current scenario, for the current technologies. Okay, yeah. Anyway, so I will skip this slide. The key enabler, so most important thing, what I am saying, the precision agriculture or smart agriculture is the computer vision. See, again, this is belongs to your core area and computer core areas. Okay, so we are adopting this technologies and we are doing so many magics. Okay, anyway, so see, there are two major things of that sensors, cameras, lidars, that's just called as eyes. In the previous slide I addressed that. And coming to next is computer vision, algorithms. Okay, that is the most important thing. So algorithms plays a vital role. Okay, these two are most important to identify the whether the crop is in good level or not, plant growth level is good or not. Okay, pesticides level is in control or water is needed or not. As like that. Weed and no more technology is there. Okay, to identify the weed, precise technology. If I identify the weed, I want to remove the weed, not from the drones. We have to use some prevention machineries. Okay, that also you can see in the forthcoming slide. How the weed is removing in the smart farming. Anyway, so I will skip the slide. As like human vision, CV is also going to play a vital role. What I said is the automotive side, similarly again the side. The replication of the same automotive technology where we succeeded, why not we can do it in the agriculture? We can do it easily. It's possible. But very few researches are happening. Very few researches are happening there. Okay. Anyway, very few academic research is happening there. Okay. And coming to these are the strategies what you have to follow there. Data collection, image enhancement, object identification, machine learning, robotic action. All the things are explained by your previous resource persons. Okay. I don't want to replicate the same thing here. Yeah. I want to give some glimpses with respect to these cameras. How this effective in the farming. Okay. The RGB cameras, multi-spectral cameras, lidar and thermal cameras. Okay, RGB cameras, it's like what I'm saying that the red, green, blue, it's like a normal standard color machines. Coming to the multi-spectral cameras, okay, it's a 2D image only. You can see that based on the NR spectroscopy. Okay, NR near infrared spectral rays, you are observing it, and from here you can identify the plant health, what the stress is there, stress of the water stress of the crop, okay, and what's the growth level of the plant. As like that, we can identify. Okay, coming to this lidar. Okay, so it is a 3D point cloud of the moon. For example, if it is open land, I can use these two sensors. If having trees, bunch of trees are there, it's like a bushy trees are there. I want to identify the growth level of the what I'm saying the bottom part of the root, or sorry, not bottom part of the one leaf or bottom part of the one root to the leaves. Is it possible to identify? Yes, you can go fill this lidar sensors. Okay, now these lidar sensors only are using in the automotive side. Okay, in the ADAS vehicles, autonomous vehicles. Okay, arrays of lidar sensors they are using. Okay, and coming to the thermal cameras, okay, it's used for identifying heat signatures. For example, if it is growth level of the corresponding is good base, okay, maybe green or blue, it generates several heat signatures. Okay, if it is dry, it indicates brown color, different heat signatures. Depending upon the change in heat, we can identify what's the growth level of the plant. Okay. Yeah, we can skip this thing. RGB cameras, multi-spectral imaging. We come into RGB cameras, so we can use the limited region. Coming here, what happens? The bandwidth is increased. And here you can see the thermal cameras, you can see the crop heat signatures and crop water stress index. That is very difficult to identify from the remaining three cameras. Crop water stress index. Okay, it's only identified from the thermal cameras and this is only used for research purpose, not for the real-time application purpose. Real-time application you can use the lidar sensors and the hyperspectral cameras. Okay, so these are the strategies of the cameras. What the researchers are using in the agriculture to identify new technologies. Okay. Yeah, this is the lidar. Yeah, what I said is lidar. You can see that from the drones using lidar sensors, we can identify the growth level of the tree. Okay, if you're going for hyperspectral, it's very difficult. Okay, if you're going for thermal also, it's very difficult. That's the thing. Each and every camera is having its own advantages and limitations. Okay, so if you want to analyze the growth level of the tree, or what happens to the bushy level or marshy level of the tree, the growth is good or not only in the upper region, in the middle region, and in the lower region, you have to use the data sensors. Okay. Yeah, so I will give the touchless networks. After that, I don't want to take too much time. Already addressed by the previous research person. CNN, object action models, semantic segmentation models. These are all the three most familiar models what's used in agriculture. Again, since I am I'm not familiar with this thing. Anyway, so we try to apply it for our user cases. Okay. CNN model is a normal generic model. Coming to the object detection model, what I applied is YOLO or recurrent CNN. What happens for real identification and location of objects? That means any beats are there between the growth level of the plants, we can identify that this beat is corresponding to this coordinates, this latitude longitude. As like that, we can identify precisely. Okay, correspond to this algorithms. Okay, as per the researchers' scenario. Okay, semantic segmentation model. Okay, here what happens? Previous things identified bead is there, but second algorithm what's identified is in that bead you can see that again whether what's the level of the bead. Fully it's brown color or now only. Okay, what I'm saying that whether it's mature or waste or now only started to decay. As like that we can identify the growth level of the bead. Okay. Yeah, this is all things you can skip it. Yeah. So one more thing you want to see here is GPS guided versus machine guided navigation systems. So GPS guided systems, what I'm saying that okay, if you have any obstacles, what happens? It never identifies. Okay. But coming to the global vision systems, with respect to coordinates units keep on working. Coming to the computer vision obstacle avoidance systems, with respect to the cameras, they can identify and suddenly the autonomous vehicles keep on moving, the tractors keep on moving. Any obstacles or any animals cross that before the tractors within 10 meters or 5 meters, what happens? It controlled and diverted from the corresponding region to other region. Okay, so that's a scenario. What is the advantages of the computer vision obstacle avoidance? Okay. Yeah, this is the most important scenario. What we have to know it. Okay. So one is level 1 assisted guidance with GPS guide for display. The level 2 is partial automation. Level 3 is high automation. Level 4 is full automation. Level 5 is complete autonomy. As like humans. Up to level 4 is a supervised. What I'm saying is up to level 4 is a supervised. Coming to level 5, it has to act like humans. Human intelligence should be there. Machine intelligence should not be there. Whatever things happening in the industry, okay, in the manufacturing industry, to identify what's going to be happen within the next 2 months, any problems going to be happen, any faults going to be happen. You can say it's a fault diagnosis, condition monitoring. Okay, with respect to sensors. The sensors what will do? Keep on getting the data and processing the data, and respect algorithm says that okay, it's fine. Right, the problem is going to be happen, or within the next 3 days, or within the next 2 days. That's all. Is it possible to address at what time what's the problem is going to be? To take a tool, how much tool here and there is going to be happen? Is it possible to identify? Very, very difficult. Okay, but it's possible human intelligence. But anyway, so mimicking the human intelligence into the automotive side and virtual side, research is happening. Okay, anyway, so coming to here, okay, level 2 partial automation, level 2 assisted guidance, level 3 is high automation. For example, the autonomous vehicles keep on moving. Okay, and it's a geo-fenced areas. Okay, with the GPS systems, it's a geo-fenced areas, and the vehicles identify that no, it is not under my limit. Okay, we are going to cross the limit. So I want to turn the vehicle from that side to another side. Is it possible? Yes, it's possible. Okay, autonomous vehicles, but with the supervised learning systems. Coming to the full automation. Okay, we are going to see all the live examples. Let's put this levels in the forthcoming slides. Okay. It's fully autonomously, but with the remote supervision obstacle reduction. The machine performance without human intervention. But human intervention not be in the with the machine, but it's going to be operated from anywhere. Maybe nearby the machine or near the system or anywhere in the world we can operate it. Again, so coming to 5, no. We make a program and with that trained program, system have to operate, and even if not trained, the system have to identify what's going to be happen, and depending upon the decision have to be taken. So that's the strategy. Anyway, so these are all the 4 levels of automation comes under the agriculture. Yeah, we can skip it. Anyway, so let I explain this task 1, lane and road reduction. Again, for example, how does a tractor robot stay perfectly centered in the crop row? For example, you can see the perception, analysis, and parallel the tractors keep on moving. Okay, and if any obstacles identified means maybe a level 2 automation or level 3 or level 4 what I am saying that. Again, it has to turn automatically depending upon the obstacles what's arriving before the tractor. Okay. Yeah, coming to the obstacle reduction and classification. We have to identify, yes, so many obstacles are there. Okay, humans are there, dogs are there, animals are there. Okay, so identify the obstacles and path navigation have to be there. Okay, navigation, path planning have to be there. Okay, so this things comes under the obstacle reduction classification. Yeah, semantic segmentation. Here you can see that. Okay, so bunch of plant is okay, growth level. We can see the growth level of the bunch of the plants. There you can segregate it. Again, as like Max said, the convention layer, as like the so many layers of that. Am I correct? Don't know what others here. And you can see that the green color indicates the growth level is good. Okay, red level indicates that growth level is good, but somewhat nutrients are very less. For example, I am saying others here. Okay, as like that, it's filtered and says that this is okay. That is 93% okay, that is 23% okay. As like that, we have to segregate, and that's the problem. A maybe the diseases are started to affect in the corresponding region. Okay, we have to take care and we have to go for remedial process. Okay. Yeah. So visual slam, I think you're putting that. If you're not able to sync with the GPS, you can go for the slam network with the cameras. Okay. Anyway, coming to the small user cases, what we work in our university. Okay, I will show to you. Automated multi-crop disease correction. Here we work for 2 crops. Okay, anyway. So I don't want to address the basics and all. We have applied this 2 models, CNN model VG16. Okay, so not myself, my colleague. Okay, so we are doing combined research. Okay, and we applied this transfer strategies, deep learning. All the things we applied, and we worked for the plant. One is tomato, one is grapes. Okay, and you can see that different vegetation index. That means what I'm saying that whether it's a good plant or affected plant or diseases starting plant, as like there are so many levels, or like we categorize so many levels. Okay, and we developed one algorithm for these 2 crops. Okay, so that's the thing. And anyway, these are the data sets. How much data is used for testing, training, validation, all things are coming here. Okay. Yeah, this is the layers. Okay, these are, we can see how much layers is taken in the deep learning again, and what we can see. Okay. So, and finally we got this different types of outputs. Okay. But you can see here user cases. Okay, you can see how the harvesters keep on working. Okay, without human intervention. What I said is I said 5 levels automation. Am I correct? It's coming under 3rd level automation. Unmanned combined harvester for rice and wheat. Multi-crop harvesting machine. Again, I think so. We can result here, boss. So multi-crop harvesting machine. Okay, so multi-crop harvesting machine means very difficult. If you take an Indian scenario. Okay, very difficult to develop the multi-crop harvesters. But coming to here, you can see it's a machine. Without humans, it's happening. Okay, it's a machine without humans, it's happening. Again, so can you replay it once again? Yeah, you can see. the tractors without human intervention, and it's autonomous tractors. Say, already it's happened. Already it's happened. The transformation of the come for India. That's okay. Okay. We can see without human interventions, maybe a rice or wheat. That is serious. Multi-crop or those tractors. Okay. Yeah. So next thing is. It's a full level automation, level 4 automation with the supervising. Okay, coming to next, please. Next slide. Yeah. So it's a machine based laser weed machine. Let you now see that the weed will be taken care, weed will be killed with that stuff using the laser beam, and finally it will be organic manure for the growth of the plant, for the soil also. You can see that a machine based laser weeding machine. You can say we are in machine. Okay, so each and every piece, how it's possible, there's the lights came and it's filling there. Right, understand that? Okay, that affects the nearby plants. That is a precise, what is uncertainty. You can think of it uncertainty. Okay, the precise thing, you can see the small weeds are keep on identifying from the arrays of cameras. Okay, and that itself, they send, we're passing the laser lights, the weeds are killing that itself. Okay, they're giving small flashes, by passing each and each waves. Okay, think of it. Okay, so here, the burned weed itself became going to be the manure for the soil. Okay, so that's the technology. We are working in the full level automation level 4. Okay, all the technologies that happen in the Brazil and this way. Okay. Yeah, coming to the autonomous tomato harvester. Again, here one interesting case is we have to segregate the tomato, not just for the size, but for the nutrition level of the tomato. Is it possible to identify, for example, what's the problem with the tomato? Very difficult to identify. Okay, but yeah, this indigenous government machine is to identify, not segregating the size of the tomato. Okay, whether it's good or partially damaged or fully damaged. Okay. So depend based on the quality, based on the nutrition also it's possible. How it's possible is that? It's that. Okay. No. See, there are several pressure cuts are there depending upon the size. Okay, we have a sensor. Okay, so what happens? Some of the rejected parts it's allowing in the soil itself, in the farming land itself, because it's going to act as a manure. The quality, quality nutrition is segregating. We are in 5 to 7 pressure pads. The pressure pads also will not be affects the tomato while it's sticking to the corresponding bin. Very sensitive issue. Okay, because we the mechanism engineers keep on working to develop the pressure pads. Once the pressure pad hits the tomato at high force which is coming from the machine, okay, we have to handle very carefully as like a soft grippers. Okay, so that's most important thing here. It is put on mechatronics side. And parallel what happens, nutrition level with the cameras we can identify it. Okay. So now this is very interesting thing. You can see the drone based apple harvesting. Okay. So here we are using the radar cameras, 3D based image cameras, and you can see the one interesting thing is there. The drones are harvesting the robots. Arrays of drones are there in the systems. It's a wire system. It's connected with a common system, but arrays of drones are there doing the parallel process as like humans. Again, picking the apples, okay, based on the what I'm picking the apples with the suitable pressure without damaging the apples, and one more thing you can see, what's the juicy content, what's the sugar content in the raw apple. Okay, that's also keep on identifying it. Okay. It's very, very difficult to learn. Okay. It's not a still startup. It's successfully launched in the farming labs. See, the sugar content measures the sugar content and segregate it. Okay, so okay, it's properly sugar content is distributed. Proper growth is there. No, improper growth is there. Partial growth is there. Again, some affected with pesticides. As like that, it's segregating and picking the apples and differentiating the different beans. Okay. And one more thing is that again you can see the pollination. Okay, they developed the robot to do the pollination. Pollination means makanam setting of demand. So from honeybees, okay, then only the growth, the leaf will become as a fruit. That pollination is also done by this. You can see the grippers. The pollination is taken care of by this machine automatically. Instead of what I'm saying, they're doing manually, honeybees are doing. So avoiding that, the machines that came to do the pollination, automatically what happens, at the corresponding exact duration, the pollination is happening means what happens, the fruit, the growth of the fruit, the nutrition of the fruit will be attained at a higher level. It has to be done by the machines. Okay. So these are the wonderful things what the Israel startups have developed, not only for picking the apples, for doing the pollinations for the different crops. Okay. Yeah. So finally, I want to say last case study is this analytical compact tractor. What we developed in our own premises, it is an indigenous tractor. So we are waiting for commercialization, which is funded by Royal Academy of Engineering in collaboration with the Cranfield University. Okay. So we, the 5 faculties joined together by collaborating with the Cranfield University professor, we developed this tractor. But anyway, now it is operated by human intervention. Okay. We keep on enhancing the autonomous tractors by fitting the lidar sensors, okay, and it should be automatically, tractor will be automatically triggered, okay, and if any obstacles identified, it has to be moved from the corresponding region. And one more thing here I want to add is, we are working for the harvesters, implements, smart implement with sustainability. Okay, we can add it, okay, and one tractor with the 5 grippers can use for fitting the seed, digging the soil to some extent. After that, seed has to be poured in that soil. After that, it has to be closed. Again, the water will be sprayed in the water in the corresponding region. As like that. Okay, our objective is to develop that type of smart implementation with the harvesters have to be fixed in the tractor. So that we keep on working. Okay, that is strategy. So this is a small tractor what we developed, and we developed the indigenous PMS motor. We are waiting for commercialization. Okay. Entire things are developed by VIT Chennai. This is a small project what we got from the Royal Academy of Engineering. It's AV tractor. It's AV tractor. That's one thing. Yeah. And one final example is that. Okay, next to this one last example is that. Okay. Again, you can see that autonomous tomato harvester, maybe a tomato or chili, whatever maybe. Okay, you can see that. Again, how the robot is doing the harvesting at night itself. At sunlight, doing sunlight and without sunlight. Okay. So where we are, our next generation is where we are. Is to develop this type of model during sunlight is very difficult. But how it's developing, okay, with the during the night itself without sunlight. Okay, so we are supply the intensity of the flux, that means light have to be supplied, and the precise forming is happening here during the night also without the humans. That is the challenge here. Okay, so and without falling any fruit from the bunches of the fruits. Okay, without damaging the fruits, that is the most important thing. For example, take grapes. Okay, grape size will be, skin will be changed. Skin layer will be keep on changing depending upon the bunches of the grapes. Okay, I have to identify it and I have to apply the force to grippers, and grippers have to pick it without disturbing the external core of the bunches. Okay. Next. Yeah. So I have so many user cases I don't want to show since running out of time. The final example you can see what I said is it's a multi-purpose autonomous robots. Okay. Again, it is done by this vessel guys. You can see that we have a robot arm which is fixed the system, going there and taking the gripper to dig the hole. You can see that always digging the hole. Okay. After that, the sealing is happening there, fixing the corresponding grippers. Again taking another thing. Again, fixing the seed. After that, we are needed for spraying the water and pesticides. There are two grippers for spraying the water and pesticides from the corresponding tank. Okay, so it's spraying the water. Limited number of required water spraying there. Okay, and water and pesticides, and after that it's happening. You can see. Again, so multi-purpose autonomous vehicle is there. Okay, digging the hole, fixing the seed, spraying the water, again spraying the fertilizer. Okay, is that suitable? What I'm saying that the width between the two plants. Okay, actually the weeds will not be there. Okay, as like that, so many strategies are there. Okay, so and final one thing is that the digital twin. Digital twin is the most important thing. That you can see here, virtual fencing. Okay, so I don't want to go for the regular fencing. It's a waste of time, waste of money. Okay, okay, that you can see this invention. We have an IoT model with some sensors, and instead of going for fencing, okay, we can develop a virtual fencing. Okay, field of sense will be there. Okay, the fencing, that's for the corresponding region, because the farmer's field is from that side. Okay, if the cat is trying to cross that, comes nearby the region, it gives the warning. Okay, maybe sensor alarms. Still it's not observed, still it's not keep on listening. I am trying to cross that fencing, nothing is going to be. Okay, the fencing will be open. Because it's developed by virtually. Again, so that type of thing is, for example, if the cows or cattle is crossed near the fencing, it gives the alarm. This is a border, automatically what happens? It turns to that side. Okay, so for small scale farmers, okay, cattle farming done automatically without human intervention. So this is one strategy what's happening in cattle side. Okay. Yeah. So what are challenges we are facing? Okay, coming to the last slide. What are challenges we are facing? Environmental conditions, data scarcity, high order of cash, safety reliability, and rural country to achieve this. Even though we are saying that we are precision producer, but abroad European countries are working the technologies of smart agriculture and implementing the smart agriculture in the real-time farming lands. Okay, so yeah, these are the problems what we are facing, but it is not a major problem. We can work on it. Okay. Coming to the last slide, future is automated and technological. You can see that IoT-based data integrations, advanced predictive analytics, personalized solutions per plant and having this problem. Okay, and finally, collaboration, data sharing. Data is the most important thing. Okay, so we are getting some data from the data source for agricultural scientists, for example, for doing the lively research. But anyway, so in future, if you have more number of data, we can do the n number of research. Okay, and most importantly, where we are studying is IoT, AI. We, the mechatronics engineers, we, the mechanical engineers, we will depend upon the electronics and computer science engineers. So what's the kind request from our side is, don't work alone from your domain expert itself. Try to collaborate with other school experts, other school students, and do the multidisciplinary projects. Okay, that will be more useful for not only for the agricultural side, the automotive scenarios. Okay. Yeah. So finally coming to the last slide. Thank you for being here. Okay. Since I have already more time, any doubts or any questions within 2 minutes, you can have it. Otherwise, we can make the discussion.
How do we like?
Labels are not needed. What I'm saying is the financial crisis. But instead of that, what I said is, again I say, small scale farmers are having more land, they're not doing the farming. Those type of skills, food structure is very good. So that's what is only. For 1 acre, 2 acres, we don't want that much of 1 acre is some. Think of it that I want a layer means very difficult to get a layer. Okay, think of the technological revolution, right? Okay, custom-made bus, custom-made. So I want to keep the carburetor. Okay, means nowadays the carburetor is going to be thrown from the vehicle, thrown from the automotive side. EV and what I am saying that the hydrogen-based vehicles already research is started. Hydrogen comes to picture. Once hydrogen vehicles comes to picture, I don't want to think of the concept of carburetor, fuel injector and all. Understood? It's going to operate for the heavy vehicles. Middle small vehicles will be grown from the market. Next 10 years, what they say is that the carburetor company is not going to be there. Okay, fuel injector company is not going to be there. Because motors, actuators for EV vehicles. Hydrogens, yes. No concepts of that. Okay. So we are adopted. Minimum levels, more productivity, without using the more technologies. The cost price, we can say cost price high. Don't say cost price high. Affordable cost. Okay, as Magellan made a revolution by giving all tractors and attracting all the farmers to purchase the tractors by combining 2 or 3 farmers. Why it's happened? All the farmers are 10 years generation old farmers. They never read about the tractor. After seeing the implementation level, how far it's easy, yes, they purchase 5 to 6 farmers combined together purchase the tractors. Now what happens? Magendra is doing the more business in Maharashtra, that means in the north side. Okay, they are the traditional farmers. They will never accommodate the human, that means technological based improvements. It's have to be happened. If not, means with the phone you keep on controlling all the things. Am I correct? Am I correct or not? Okay, next 10 years you can control your mobile. You cannot control all the things from your house using the mobiles. Am I correct or not? Given the construction, doing the construction, I want to construct the house, for example. Okay, I want to purchase the house. Go to the constructors. Now what happens? You can see that they are giving the CD. Okay, that is the reality of your house. We have a field of experience of your house. They are giving the CD. The concept of digital twin. VR. Without purchasing the apartment, you can have a field of and you have the rights like this. Right should be like this. Or paint should be like this. That's like this. We also given to you. Okay, if you are not replacing, then you are going to lose.
So, I had a question. If the area is about 2 acres, in some particular place, it has submitted by some yellow. So, in that condition, what type of camera is
Actually, not for, if you're going for 2D image capture, you can go for the if you have irregular contours, irregular terrains performing that, you can go for radar cameras. But affording the camera picture will be the to identify the more level of the corresponding details within the structural areas. If you add more terrains, uncontoured, irregular contours are there, again,